Okay, so now this problem will be solving by method of joints. So you can see in this problem there are both types of load, that is one vertical loading is there of 100 kilonewton and one horizontal loading is there of 80 kilonewton. So in this case the only difference that you will find it here is while calculating the reactions in step number 1. Initially we were taking sigma fx is equal to 0 and almost every time this HA was coming as 0. But due to this horizontal reaction, we will get the value of HA now. So by using the conditions, we are getting HA is equal to 80. Similarly, doing the same procedures, we will get VA is 93.33 and VD is 6.67. Now considering the method of joints, that means first we will consider joint A and find out the forces in AB and AF. So considering joint A, these are all the forces, and here the angle you can find out by using the tan theta. So let's say this is theta 1. So tan theta 1 is equal to opposite side by adjacent side, so that both are 4. If tan theta is 1, that means theta is 45 degrees. Okay, so now this is 45 degrees. Now we will apply, after resolution of 4, sigma fx and sigma fy is equal to 0, and after calculating it we are getting FAB as 131.99 minus FAF is 13.33. Now just pay attention to this first diagram. So here you are getting FAB value as minus 131.99. That means this negative sign denotes the direction is opposite. We have assumed it away from the joint A. Away from the joint, we have assumed this direction. Okay. As it is coming negative, that means our assumption was wrong. This is to the opposite direction. What about FAF? This value is coming as 13.33 and it is coming as positive. That means whatever direction we have assumed, that is correct. So making the changes, our diagram should look like this. The FAB should be pointing towards the joint A and FAF should be away from the joint A. Now these two directions we have to mark it on our main diagram. So you can see this green signs here. This green sign is showing that it is towards the joint and this FAF sign is showing that it is away from the joint. Now similarly, to balance these two forces, there will be some forces in the member. These are represented here. By looking at this, we can see that this member is in tension and this member is in compression. Same thing will carry out for the joint F. We'll apply the conditions and we'll get the value of FFE 13.33. Same procedure we have to follow for the remaining joints, that is D, E and C. So you can see the joint D is here. This FDC is resolved into two components. Same thing, apply sigma fx and sigma fy is equal to 0 and get the two values. If the values are coming negative, then you have to change the direction. Similarly for joint D also, you resolve the forces and then apply the sigma fx, sigma fy, and at the last you apply it for the joint C. Now if you just pay attention, then this method is the method of joints. Okay, so let's say this is a joint here and this is a member which is connected to a joint. What we are considering here right now is we are considering a joint, not a member. So this joint is applying one force to the member. Similarly, the member is also applying some force to the joint. Now we are calculating this force. Okay, so we are calculating this force. So if you take the same example of joint A here, then this is the member AF. Okay, this is AF. This joint is applying FAF force on the member. What we are considering is we are considering only this part. I hope it is clear now. So to balance this force, to balance this green force, there should be some red force which is acting and the direction of red force should be opposite. That means if this is, we'll take the exam this only. What was the value of FAF here? FAF was 13.33. So if this is 13.33, then this value should also be 13.33. Then only this will be balanced. Now to balance this member, on left hand side there is 13.33, that means on right hand side there should be 13.33. Okay. Now if you just look the central part is nothing but the member. Okay, it is the member and it is subjected to the two forces in this way. Now by looking at this, you can say that this is in tension. So same thing we have given it here. So first you identify what is the direction of the force at the joint. Remember, we are discussing method of joints. So we will be taking only joints and not members. In method of sections, we will be considering the force directly in the member. So at that time you don't have to write these arrows or draw these arrows here. But however, while solving by using method of joints, try to give these directions of arrows so that there will be no confusion whether the member is in tension or compression. Okay, so this once again I will repeat, the green arrows represent the forces at joints and the red arrow represents the forces in members. The both things are different. What is asked in the question is what is the nature of forces in members. So for that we will have to use this sign convention.